So is anyone stuck? I think, you know what? I'm guessing no one is stuck on any of the worksheets because we seem to be doing them all during class time these days. So maybe there's no questions, but I would love to take any questions you all have if there's anything that's come up from last week. Okay. I suspected that, and that's totally cool. At any point, if a question pops up that you've forgot to ask, please feel free to ask them. Yes, I love that. What we're going to start with today is a review, an overview of chapter 3, and then we're going to do practice problems. So the overview is going to be what we typically do on review days is my reference sheet suggestions. And I'm going to do them by section. And for this unit, it's mostly just like, hey, here's all the formulas you're going to need to use. And you're going to need a reference sheet with all those formulas, or you're going to be in trouble when you take the final exam, because I'm not giving you the formulas on the exam. You are expected to have them written out in a way that makes sense to you, and that you know how to use them. So, I have all these formulas memorized, but that's mostly because I've been teaching this for, I don't know, 4 or 5 years now. I've probably taught 20 sections of this course. So I've done this like 20 times, and eventually repetition sticks things in your head. So I don't expect anyone to have any formulas memorized. I just expect you to recognize from the problem the words that tell you what formulas to use, and then that you can find the formula and set it up and use it and get a result, and then interpret the result of that formula. So first, a little coffee, and let's start with 3.1. 3.1 is the simple interest stuff. We already did this, but I guess it's worth checking it again. I might even need to stand for this. Let's stand. So there is the interest formula. I equals P times R times T. So I suppose we should label this simple interest. And then remember, we solved this like we could have solved this 3 different ways, and we could say, oh, P equals I divided by RT, and R equals I divided by PT. I don't know if these formulas are particularly useful for you. And T equals I divided by PR. There were questions where you were given 3 of these 4 items, and you were to find the 4th one. And mostly in the textbook, you just did it through algebra, right? You wrote the things in here, and then you divided by the pieces. But you could also just know these different formulas, these different versions of it. Okay, and then by the way, notice I am not labeling what these letters are. I'm leaving that. At this point, I kind of expect you to know those. If you don't, that's okay. Write down what P stands for. It's principal. It's the amount of money you start with. And remember, we use simple interest in savings calculations, but we also used it with student loan calculations. So this formula showed up in 2 spots. Okay, then we had the future value formula when calculating simple interest. And remember, this means the value in the account after T years. So there were 3 versions of this one. It's the principal plus the interest, where I equals PRT. So we could rewrite that as principal plus principal times rate times time. That's just replacement of I. Or we could factor the P and get a version that looks really similar to the exponential version, P times 1 plus RT. You only need one of those 3 for calculating future value. You do need to know what we mean by future value, and that A represents that future value. And that's it for simple interest in terms of formulas. A couple things to note. You should know the difference between interest, which the units on that is amount of dollars, and interest rate, which the units on that, it's a decimal version of a percent. And that percent is almost always annual, meaning we give you a percent per year. Remember, when we dealt with credit cards, that percentage rate was often monthly. I'll put a note here. This is typically years. It's assumed years unless otherwise stated, that the time we're dealing with is 1 year at a time. Doesn't have to be, but it typically is. Okay, that is 3.1. Any questions on 3.1 stuff? Anything you think I'm forgetting? All right, let's move to 3.2. So 3.2 is compound interest. I'm going to label that at the top, compound interest. And I'll put it in the same format. If we want to calculate interest, unfortunately, we can't calculate interest directly in the compound interest deal. What we first have to do is calculate the future value. So how much money is going to be in the account, or how much are we going to owe? This is the same calculation as the finance charge, by the way, for car loans. So it's the amount at the end minus the beginning amount. That gets us the interest. Okay, so that's that. And then there are 3 future value formulas that go along with compound interest, and they're all, 2 of them are the same and 1 of them is different. So there's the compounded annually, which is kind of a useless formula. I almost would say don't even bother with this one. I better write it correctly though, hadn't I? So this is compounded annually, so once per year. There's the same version of that formula when it's compounded in times per year. So this is in compounds. And you may, I know sometimes in our co-rec courses, the co-teacher helps when they were helping students work with this one, they write out the words that go within. So monthly being 12, semi-annually n equals 2, quarterly n equals 4, yearly n equals 1, all that kind of mess. And then the last one, the last future value formula is the compounded continuously, which is P times E raised to the R times T. So this is compounded continuously. You need to watch for the language in the problems to determine which of the formulas are you going to use. If it says compounded X amount of times per year or N amount of times per year, you're using this one. If it says compounded continuously, you're using this PERT one, and you need to remember that E is a number. And then we talked about, there was another formula, we talked about like which interest rate is best. And remember, the more often you compound, the more interest you earn, but there's kind of a limit on it. That's what the E was about. At some point, there's a maximum amount. And so it's not always like very obvious which one is the better one. So we have this little effective interest rate formula, which allows us to compare different compounded formulas per year. So these different interest rates, different APRs. So the effective interest rate is this E, and it's equal to 1 plus R divided by N raised to the N power minus 1. You'll note that this 1 plus R divided by N to the N is this, it's right here. So we're just pulling one piece out of the future value formula and saying this allows us to compare compound interest rates. Remember, what it actually does is it converts the interest rate to an equivalent 1-year simple interest rate or 1-year compounded annually interest rate. It's the same amount. So we can have all these different compounds per year and slightly different interest rates, and we convert them all to a simple interest rate, 1-year interest rate, and we can see which is best. So for investing, you want the highest interest rate, the highest effective interest rate. If you're borrowing, you want the lowest effective interest rate. That's it for compound interest. So I want to pause here, and I want to jump to the worksheet, and I want you to try question 1. All right. So this gives you several different interest rates, and you're asked which is better. One little typo, D should be 4.9% compounded secondly. So I'm going to set you loose. I'm going to suggest that there is no P here. So you can use a P and calculate future value, or you could use the effective interest rate here. This is really what I was pushing you towards. Use the effective interest rate and see which is going to be the best. I'm going to give you 5 minutes to attempt this, and then we'll come back and chat about what you've done. Set a timer for 5 minutes. Okay, how are we doing? Anyone attempt this problem?
I'm stuck on the monthly one.
So let's see. Okay, so really, what we should decide is how are we going to compare these different accounts? And maybe first, it's important to note that since we're doing a savings account, our goal is to see which one's going to earn us the most money. So when you say you're stuck on B, or what do you mean? Like, what did you do for A? That really annoys me that that's a $sign there. I just so badly want to fix it.
I just decided that I was going to use $500 as
Okay.
the initial. So I did 500 times 0.0501. And then if I wanted to get a future value, I just add the 500 back.
Love it. So you did it for 1 year, is what you're telling
Yeah.
me.
Yep.
500. Okay, I like that. Let's do that. We'll go with that strategy. So what we're doing is calculating a future value where we invest 500 for 1 year to compare these. All right, I'm with you. So then so for simple interest, if we're looking at our formulas, we're just doing like one of these three. Excellent. Okay, so for monthly, actually, let me just finish writing this down. And that's going to be some sort of number over 500. So for monthly, let's see, what's the, well, which formula are we going to use for monthly? Maybe we should start there. We know it's compound interest formula. We'd better do a future value. Which one of these three should we use? Number one, number two, or number three?
I was going to use number 2.
Love it. Good. And then the thing we just need is what's in R, because P and T are the same.
So R would be 4, I think. And then N would be 12.
Nailed it. Now, instead of 4, you mean 4.98, right? So 0.0498, I'm assuming that's what you meant. Unless we have different numbers.
Oh, no. I was just doing 4 out of 12 because 4 times a year.
Well, so, I love it. I love that you said that. So we are compounding it 12 times per year because of the word monthly. The rate is the percent we're given.
Okay. That makes sense.
Nice. Good. So then for C, we would use the same formula actually, because it's a compounded in daily and secondly. It's just now our N is 365 and our rate is slightly different, 0.096. And then D compounded secondly. Yikes. How many seconds are in a year is what we have to answer. So let's see, 24 hours. Wait. Let's start with the 365 days from before. There's 365 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. So whatever that is, that's the number of compounds per year if it's being compounded every second, and we're using the interest rate of 0.049.
So are the R values that you have, is that, so like for B, it would be, that's 1/12 written in decimal form?
No, it's literally this thing right here.
Okay.
It's the interest rate we give you, the percentage converted to a decimal. And that's what R always is. We always have to hand you some sort of interest rate, unless we're asking you to calculate it in a simple interest problem.
Okay, I got it.
Good. Okay, I'll give you a second to do those calculations, and then you can check from there. Did anyone else do a different strategy? Or are we all on the same page? I'll give you like 4 minutes to try this. Nice, Alyssa. Did you use the same P? It will, I mean, if you used like 100 or $1 or $1,000 or $1 million, it will make a difference as long as you use the same P value for each scenario. Okay, perfect. All right, I'll give you I'll give you the 4 minutes to finish up whatever you're working on for this, and what I'm interested in is the result, as in which one is best and why. Okay, which one's best? While you all are typing in your answer to me of which is the best, I'm going to show you maybe a simpler way to do this that might have been a little bit less work than what you did. It's totally fine that you all did it that way, but what we just looked at in the reference sheet material was this effective interest rate. It doesn't need to take into account P. So what I'm going to do is calculate the effective interest rate for each one of these scenarios, and we can look at those directly. And that still may not be a good enough of an answer, but it's a start. So 1 plus 0.0498 divided by 12 raised to the 12th power minus 1. And I'm just going to copy and paste this a bunch of times. 1, 2, 3. So then I'm going to change it to 96 divided by 365 and raise it to the 365th power. And then, oh, I guess I got too many of these. And then the last one, we're going to do 0.049, and then we're going to do that crazy multiplication. 365 times 24 times 60 times 60. Whatever that is, we're going to raise that. Oh, come on now. Come on. Let me put that over here. Okay. So I'm going to list out then the respective interest rates for each of these. So this one is 5.095%. This next one is 5.085%. Oops, that's a little bit less. So currently, compounded monthly is better than the compounded daily rate. And then the last one is 5.022%. So between those three, compounded monthly is the best. Let's just then toss in, well, let me write them here. So A is 5.01%. B is 5.095%. C is 5.085%. And D is 5.022%. So the best option for within 1 year's time is option B. Is that what you all got when you did your account balance method? Did you get that option B would have the highest account balance of the 4? Okay, nice. Now, what we know about interest rates is that after a 1 year period, this is no longer a comparable interest rate. It was the smallest of the three anyways, so after a 1 year period, even after 1 year, it underperformed the rest in terms of savings. So this is going to be the best no matter the length of time. Because these are all annual compound interest rates that are equal to these compounded monthly, daily, or secondly interest rates. So really B is the best for all time lengths. What do y'all think about that? I think what I'm most interested in is, do you understand how to think about this problem? Because it's a pretty complex problem. I'm not asking you to just find me an account balance. I'm asking you to determine which one's going to earn you the most money.
I am still not typing it in correctly. And I guess that's probably, I'm not really thinking about the problem right, I think.
Well, your answers are going to be totally different than what I've got. Because what I've got here is a completely different method of solving the problem than what you did. Let me save this. Do I want to save this? Sure, why not? Let's say unit review A. I should say what this is, right? This is unit 3 review A, number 1. So Mike, if I were to do what you did, which is totally acceptable, I would, for my first one, I would have this. For my second one, it would be 500 times 1 plus the 0.0498 divided by 12 raised to the 12th power. Did I do that? There we go. Oops, not 23rd, 12th. And then we just need this 2 more times. So if you're using that 500, oops, screw that up. Is this looking like what you have now?
Yes, it's starting to. I forgot to put the 1 plus that. So it was giving me like a really small decimal instead of the future value.
Gotcha. Let me get these typed in here, right? Cool. So what you're doing is looking between these three, and they're all $525. So you're looking at the amount of cents you're earning. 5 cents versus 48 versus 42 versus 53. Ooh, oh, it's because I put in the wrong thing here. This was 90. There we go. So for yours, your method, and Alyssa, yours as well, you're looking at which one earns the most, and that's still option B. Because it gets you 48 cents as opposed to 42, 11, and 5. Does that feel better? I see what you're saying, Mike. If you did this, well, yeah, that's a tiny number. It's like you get $0. Congratulations.
Yeah. I'm getting it now.
Good, good. Okay, so that's that problem is really kind of a direct application of all of these formulas. You could have solved it with just this one, or you can use the different future value problems to compare the interest rates. And both methods are equally valid. I don't know that one is better than the other. One might be a little more efficient, but that doesn't particularly matter. Okay, so let's look at, why did I write 3-1 here? Let's at least fix that. This was supposed to be the 3-2 stuff. Okay, I'm going to go to a new page. Nope, I can do it on here. So 3-3 is the monthly interest formula section, and it's when we did car loans. So car loans had a bunch of different stuff with it. So we'll just put on here loans. No, because then we did student loans and mortgages. So this is car loans / credit cards. All right, so we had things like the principal was the price minus the down payment. And then we had like the finance charge. Now, I liked to use the finance charge this way. It's different than what the book did. It's the monthly payments times the number of monthly payments minus the price. That's the finance charge. And really, those are the only two I think we need. And then we had the monthly payment formula, which is the principal times the rate divided by 12, because this is a yearly interest rate, and then 1 minus 1 plus the rate divided by 12. And we used negative n here. And this n was the same n as here. And that's the monthly payment formula. We then had another formula, which was the unearned interest, and we used the rule of 78 formula to calculate this. It was F times K plus 1 divided by N times N plus 1. And then there's a total cost formula. And the total cost formula you could think of is it's the monthly payments times the number of payments plus the down payment if there was a down payment. And those are kind of all the formulas you need for 3-3. I suspect at this point you have this thing memorized, especially if you did the ALEKS problems related to monthly payment stuff. And then there were two other things in this section. For credit cards, there was the unpaid balance method versus the average daily balance. And if you recall, those were the average daily balance was kind of a tedious sort of structure. You needed to think about, you kind of, I don't know, you might want to think about how to write that down, what the steps you have to go through to calculate the average daily balance. There is not a straightforward formula. The fee itself is super straightforward. It's just unit one. Can you calculate percent of? The difficult part for average daily balance is finding the number to calculate the percent of. So you had to have like a balance times the number of days, add all that together, divide by how many days in the month, and you had the average daily balance that you then multiplied by the percent. Any questions on those?
I guess I don't really have a question because I don't really know exactly how to do all that stuff. Even though like I was in class that day, like the credit card stuff was super tough.
Yeah, I mean, I would call it tedious. I get, there's like, you have to remember all the steps to go through. Here's an example. Calculate the average daily balance of the following credit card. So we'll come back and do this one together, and maybe as we do this, we can write down the steps. This is a really tedious one because I gave you a huge set of problems. And then here's a monthly interest. Thing. So let's see. So let me finish. How about I finish this and then we'll come back and see if you can do these problems, because the other two, so 3-4 is student loans and mortgages, and there's not much new to it. Did I say 3-4? I meant 3. Yeah, I didn't mean 3-4. This was 3-3. Yeah. So 3-4, student loans / mortgages. And really, with student loans, you just need to know two things. Is it subsidized or unsubsidized? So if the loan is subsidized, you're just borrowing P. If the loan is unsubsidized, you're borrowing P plus any interest while in school. Let's not say it that way. We'll call it deferred interest. Right. And so remember, it was like while you're in school, your interest is deferred. That's not even how you spell deferred, I don't think. Here, let's type it. Yeah. Let's see if I can do it. Deferred. Well, I did spell it right. Wow, I feel pretty good today. That's wonderful. Okay, so any deferred interest gets added in, and recall that this is simple interest. So you do I equals P times R times T. From there, you calculate your monthly payment the same way you did it with a car, except it should be a minus 1 plus R over 12. We used negative 120 because it was a 10-year loan. And that means you're going to make a total of 120 payments. Total cost on this, by the way, is just M times N. So we could write down that little formula. Total cost equal to M times, in this case, 120. If it was subsidized, same thing. You're not paying the interest. Sometimes we like to ask you, like, is it worth it to pay? Is it worth it to pay the interest while you're in school? And so then, if you're the one subsidizing yourself, like if you're paying this interest, then you would add the interest to the total cost, but you would calculate your monthly payments off of the subsidized. Okay, so then mortgages are super similar. Let's change color for once though. Let's go back to purple. So mortgages are just even longer than the other two. They tend to be 15 to 30-year loans. The difference here is down payment was often equal to a percent of the cost. If you look at your project, I ask you to do 0%, 10%, and 20%. And then that means, just like your car, you are not borrowing all of the price of the house. It's the price minus the down payment. So you are borrowing only what you need. Banks will not loan you more than what you need, unless you can do some improvements, show that you're going to mess with that. So the monthly payment formula is, again, it's the same thing, except that instead of negative 120, we do 12 times T. I know the textbook does NT, which doesn't quite make sense to me, because it's always, if we're in years, you're just going to do 12 times the number of years. And then, just like the car and the student loan, total cost, I guess I should have stuck with cost, that's going to be the monthly payments times the 12 times T. So the total number of payments you're going to make, plus whatever you made as a down payment. And that's the total cost of your home. Okay. The last two sections, there's not a lot to write on your reference sheet per se. You just need to be able to calculate profits. And I guess we could write that as the profit equals proceeds minus the cost. And there it's just some multiplication, like, do you know how to calculate percents of from unit 1? Do you know how to read a stock ticker? Do you know what the stock price does and how many shares you have of a stock and that kind of thing? And then there's like percent return, which again is a return to unit 1. That's just profit divided by cost. And then there's annual return. We could call that the annual return rate. And that's just the percent return divided by time in years. Let's just write years. So if your time is less than 1 year, you're dividing by a small number. 3.6 is then also just taxes, and there's not really a formula I can write down. You just need to remember how to calculate the progressive tax rate on taxable income. So remembering it's a percent of the amount of money within each bracket. So there were a few little tricks on that one. Okay, so do I need to pause? I did that really fast. Is everyone able to, did you all get written down what you needed from what I've written down? Do I need to go back anywhere? Okay. So let's skip back to the Unit 1 Review A. And let's just go to number 2. Let's start there. Let me give you 5 minutes and see if you can't figure out how to answer this problem. You're going to look at your reference sheet and find which formula are you going to use. If you've already done this problem and want to like move on, you could try to do questions 11 and 12 on page 84 for Unit 3 Review B. So for now, we're going to do this one, and then we'll talk about your result. Set a timer for 5 minutes. Okay, how are we doing? What formula did you all use for this one? And how did you know?
I used the same.
Excellent, y'all. Good. Because of this, we're going to do A equals P raised to P times E raised to the RT. Good. So 6,000 you noted was P, T was 20, R was 0.0324. Now I'm gonna guess that maybe y'all got the wrong answer, but we'll see. Hopefully, maybe not. Most students tend to get this one wrong because they miss the word how much interest as opposed to future value. So just in case you're forgetting, E is a number. So just type that in Desmos as E. Even if you're using some other calculator, it will have that there. 0.0324, whoops. 0.0324 is that, and then times 20. So we get that the account balance in 20 years on this 3% compounded monthly. Notice I have the wrong answer, by the way, because I didn't do this right. It dropped it out of the exponent, that times 20. So we get that the account balance after 20 years is $11,470.28. Is that the answer you all had? Okay, nice, Mike. You have the right answer. This said, how much interest will you earn? This is future value. So interest, recall, is the future value minus the principal. So we need to subtract from this $11,470.28. We need to subtract the 6,000, and then you actually have the right answer. Like it's really just a test of, are you paying close attention to what the question is asking? And that means your final answer is the 5,470.28. Be mindful of that when you take the final exam. Like, sometimes it's just the minor details that can get you caught up. Okay, cool. Any questions on this? Are you all feeling pretty good? Let's skip to number 3, unless there's a question. Okay, good, Alyssa. All right, so this one says, should you make a down payment of $2,000 when purchasing a $15,000 car with a 60-month loan at 7.35% interest? Okay, it's a vague question, right? And you might think, oh, I can just answer it right away, but I'm going to demand that you show some work. So does anyone want to talk through what they're thinking should happen? No takers. Oh, there we go. No idea, no clue. Okay, okay. Let me ask you this. If you were going to decide um whether you should pay $2,000 down or not, what thought process would you go through in your, or like, how would you determine it? Not what calculations would you do, but what would be your decision process like?
Like, how much more am I gonna pay if I don't put $2,000 down? I don't know.
Love it. Love it. Yeah. So what we need is some total costs here, right? Total cost calculation. And remember, that's the monthly payment times the number of payments plus the down payment. Right? So if we split this, we would have one total cost would be this if we did the down payment of 2,000. Over here, maybe we'd say, let's just make cost equal the monthly payments times the number of payments and no down payment. Let me move this over so this looks better, right? Okay, with that said, do you know how to calculate the monthly payments for each of these? So let's look at our reference sheet. Is there anything on here that helps us calculate a monthly payment for a car? Anyone see it?
The M equals P times by R over 12, that one.
Nailed it. So note, I did not label this one. Why don't we label it? Monthly payment for car loans, right? Yes. So you're going to calculate this, which means you need to know what's P going to be. And notice P is the price minus the down payment. So in one scenario, right, you're going to do that. P is price minus down payment. That I have it set up here. In the other scenario, you're not going to do that. So for one scenario, you're going to borrow $13,000 and calculate your total cost. The other scenario, you're going to borrow $15,000 and do the total cost. So let me give you 5 minutes to see if you can figure that out, and then away we go. Set a timer for 5 minutes. And if we need more time, I can add more time. All right, anyone got an answer? Really, I should say, does anyone have a monthly payment calculation for either of these two?
I got 259.57 for the first one.
Okay.
For the second one, I got 299.50.
Alrighty, let's see if I agree. I do agree with that one. And let's see if I agree with this one. I think I did. I don't know what you all said. Cool, good. 259, 57-ish roughly on this one per month. And now this one is 299.50. So let's see, what's the cost going to be? 259.57 times 60 plus 2,000. Right. So this one, the total cost we're paying for this $15,000 car is $17,000, $574.20. So we're paying what, an extra $2,574.20. So then the second one is this. We're paying $17,970 for the second one. Not a huge difference between those two, right? So we're paying an extra $395.80 between the two. So $395 extra. Spread over 60 months. So it's spread over a 5-year time so that we don't have to cough up $2,000 at the beginning. So this is the work I want to see. And then your discussion, your answer to this question is going to depend on your own thought processes. There is no correct answer. There's good answers and there's bad answers. And this question is really what the project is about. One of the questions in there is like, should you pay it off early, or should you make a down payment, or, like pick the best scenario and talk about why. So things you can look at here is say, oh, I have $40 more a month in my monthly budget to spend on necessities between these two different things, right? So it's a smaller monthly payment. Another thing is we pay less over time. But then the other thought is, well, I had to come up with $2,000 cash to buy this car, and it really only cost me $395.80 spread over a 5-year length of time to not come up with that $2,000. So your argument is about which of these scenarios makes the most sense for you, and it's really going to depend on, what the situation is. If you're wealthy and have tons of money, you just pay $15,000 and you don't need any of this, right? None of this matters because you just pay cash and you save the most money. So I'm not allowing you to think of that scenario, I guess, because I'm forcing you to borrow money. Does that make more sense now, y'all? What's going on here? Cool.
Yes.
If you look at the Unit 2 Review B, which was what one of the exam questions was in prior years, like pre-COVID, you'll see it was a little more straightforward of a question. It just said, calculate the monthly payment given this criteria. And then there's a payoff amount, and then there's the question, is it worth paying off? So instead of this really open-ended question on the exam, I kind of gave you some structure to it. Note here on question 15 that this doesn't matter. Use the rule of 78. Use the unearned interest formula for rule of 78. So you're paying the loan off a little bit early. Okay, let's skip back to our review A, where we're at. All right, we've done all that mess. Now we get a student loan problem. Do you all know how to do a student loan? The only tricky part is keeping track of what happens with this and the fact that it's unsubsidized. Note the question is, how much are you going to pay for your loan or your schooling? Okay. Yes, let you try. I'm going to give you 5 minutes to start. If you get stuck, if you're like absolutely unable to get moving anywhere, call me in and I'll give you some more hints. I think it's better if you do try to get there before I do. Set a timer for 5 minutes. Excuse me.
I'm not seeing on the reference sheet where the formula for that is. I've just been like screenshotting the formulas and using them
Formula for what?
for unsubsidized loans.
Okay, so the formula for an unsubsidized loan is that the principal you actually borrow, so the actual P, let's write it this way, is the principal plus the interest. But the interest is simple interest, so you have to calculate that first, then add it to the loan amount. Maybe we should not put P here. Loan amount. Let's do that. So let's rewrite this reference sheet a little bit. So for a subsidized loan, the P is equal to loan. For the unsubsidized, the P is equal to the loan plus the interest that's been deferred. So you're going to calculate simple interest on this, where T is the amount of deferment time in years. And then it's the same exact thing as a car. It's a monthly payment formula, but it's a 10-year loan. Does that make sense? Is that helpful?
Yes, I think I'm gonna wait though. I'm gonna
Okay,
wait
no
this.
worries. Okay. Anyone get the amount of simple interest that accrues on this loan? I'll put my pen. I'm just going to do it. So simple interest is, ooh, that looks about right. This is 23,000. It's times is 0.0435. And then it's times 2 years plus 3 months, which if I divide that by 12, we get the same amount of years. Does that make sense to you all? Question is how many months in a year? There's 12. So 3 months is what portion, what percent of a year, if you want to think of it that way. It's a quarter of a year, 0.25. So Jennifer, how did you get 4,000? 13.
Probably because I just put 27 months.
Oh, that'll do it. If you did 27 divided by 12, you get the same thing. But if you do 27, oh, you get a crazy big number. Is that, wait, 27 months? Yeah, that makes sense. Why is my answer? Let's see, 2 plus 3 divided by 12. Yeah. Okay. Does that make sense, everyone? So this much interest is going to be accruing while your payments are deferred. So while you're taking your classes and doing your stuff and then you graduate and whatever, you end up with this much interest being charged. Now, since it's unsubsidized, the principal we're going to have to repay is the initial amount we borrowed plus this amount of interest. Now, this is also not totally true because there's origination fees, which are usually like 1.25%. So even a percentage of this gets taken away. Usually it's just they give you less money than what you borrowed, which means you might have to borrow more than you actually needed, blah, blah, blah. It's kind of a thing, right? It would be so nice to just have money and then you wouldn't have to worry about anything. But, money isn't everything. Okay, so here's the amount we have to repay that we got to start repaying once we get out of school. So then you smash this into the monthly payment formula. And the one thing that's not listed up here that you are to kind of understand and assume is that the number of payments is 120 because loans tend to be 10-year loans. So we're just going to calculate this as the $25,251.13 times 0.0435 split into its 12 months, all that divided by 1 minus 1 plus 0.0435 divided by 12 raised to the negative 120. So let's get that number. Hey, that's not bad. $259.88 a month. Basically the same amount as that car loan. Yeah, it's almost exactly the same. But look at the difference. The car loan we borrowed 13,000, and we paid it back in half the time. Here we're borrowing 23,000, and we're paying it back in 10 years. So this was not the answer. What we wanted is the cost. And since we rolled the interest into the amount we borrowed, and we're going to spread that over 10 years worth of payments, you're going to do 259.88 times 120, and this is the cost of your education. I'm gonna just take this number I have here, do 120. Yikes, you're doing $31,185.21. Ouch. What is that? An extra $8,000? Yep, 81.85 is the fee to borrow it. The good news is it's spread over 10 years. So it's not like super duper awful. Like you don't have to pay that all right away, but for 10 years, you're making a $259 payment. Okay, questions, concerns, comments on that? Again, this question is kind of a higher level question because I just said find the total cost. So you need to know all the bits and pieces that go together to find a student loan. Like I really like this question. I think it really tests your deeper understanding of what's going on with the problem or what's going on with all the stuff in here. The one on the previous exam, so the Unit 2 Review B question, looks like the similar question is on page 88. And instead, like I give you some of the monthly payments amounts. Like here, I'm like, hey, find the simple interest. So I don't force you to remember that you have to calculate simple interest. I tell you to find it. And then in this case, I told you the monthly payments and I want to say how much extra did you pay, which is essentially this calculation at the end here. Okay, questions, again, comments, concerns. Did I lose anyone? I did that kind of fast, I think. I don't know. I've had a lot of coffee. Time is kind of relative right now.
Did we have to do this the second half of that, the monthly part of it, because there was the deferment?
The deferment's right here. So this simple interest calculation, this one right here, is because of the deferment. So if you do take out loans, you are being charged simple interest on those loans. Although right now, if they're federal loans, which are the ones you want to take, the interest is 0% because of COVID stuff. It'll bump back to whatever it is shortly. Now, if you're getting grants, like if you get a Pell Grant or something like that, I believe those are just kind of free and clear. I don't think you pay much back, or I don't know that I'd have to, maybe don't quote me on that. Maybe I'm wrong. And then also some of the veteran benefits. So if you served in the military, that money is free money, essentially. It's like a thanks for signing over your life to us and potentially dying. Here you can go to school kind of thing. And of course, there's all kinds of rules and stipulations on Pell Grants and veteran, veteran benefits. But I don't think they charge you interest on those or make you pay them back. Mike, did that answer your question about the deferred interest?
So I would have stopped at the 25, 21, 13 because I don't know, like why do we have to calculate the monthly payment? Is it because interest is accruing each month or something?
Yeah, right. So what happens is you borrowed, this is how much money you borrowed. This is how much you owe once you have to start making the payments. And what happens with these types of loans is they convert from a simple interest loan to a compound interest loan, and interest is accruing on this $25,000 as you make payments. You want it to switch to compound because as you pay down this amount, the amount of interest that you're getting charged decreases. So this monthly payment takes that into account, and it spreads out the amount you borrowed plus the interest that's being charged off of that over a 10-year length of time, and then you make equal payments. That's why it's called an installment loan. So this is how much you're going to pay every month. And at the beginning, a large portion of this just goes to pay the interest you're being charged, and a little bit goes to the principal. And over time, that flip-flops, and you're paying more on the principal because there's not as much interest being charged. So this is what you're going to pay every month for 10 years. And when you multiply that out, you get how much total you pay over the lifetime of that loan. You borrowed this much. So this is the cash you didn't have that you borrowed. Really, you only borrowed this, and this was the cost to borrow it while you were in school. This then is the total cost at the end after you've made all the payments. Is that helpful?
Yes.
Okay, good, good. I mean, so like the difference with a car, you just borrow the money and start paying it right away. It's like you're the middleman between a bank and a car dealership, and the bank hands the car dealership the money, and then you're on the hook to pay for it, and it just starts right away. Whereas with school loans, the reason there's this deferment is the assumption is you're not working while you're in school, which isn't true for many community college students, but for some it is. So you're not required to pay your loan while you're in school, because we're going to give you time to get your degree and then go out and get a job. And then after that fixed amount of time, the assumption is you have a job, that you're making more because you have the degree, and now you can afford these payments that you maybe couldn't afford while you're in school. So that's why there's these deferments. But like we're like, hey, we won't charge you, we won't make you pay, but we're still going to charge you. And this is that charge. All right. I'm just going to show this problem again, just like I did last time. And what I challenge you to do is write down the steps of what I'm doing. Like, what is it that you have to do to calculate the average daily balance of a credit card? Like, how does that work? So if you recall from the previous problem, we need the date, we need the balance, we need the number of days that the thing is at that balance, and then we're going to multiply days times balance. Is this ringing bells for you all? Should I make you all do this yourself? I'm not going to. I'm just going to do it. Okay, so we're told that on February 1st, the ending balance was $211.14. So then our March 1st, we'll call that 3.1. It's $211.14, and then on 3.5, we got to change. Oh my goodness, this problem is such a mess. Look at all these things here. 10, 11, 16, 16, 16, 13, 20, 19, 20, 20, 20, 21, 18, 23. So this is all over the place. So let's see if we can't organize it. 3, 5, 3, 10, 3, 11, 3, 6. Oh, nope. 3, 13 comes next. Then 3, 16. There's a couple 3, 16s. Looks like then 3, 18. 319, 320, 321, and 323. Those look like all of the dates we have to keep track of. I don't know if anyone sees something that I'm missing. Feel free to shout out if that is the case. Let me make this bigger, and we'll make that a little bigger. There we go. Okay. There we go. All right, so it looks like we made a huge purchase on the 5th. $1,221. Let's just say those are my Legos. This is annoying because 3-1. This doesn't work, does it? We'll do it like that. 310. Notice I'm doing equals. I'm selecting the previous balance. On the 10th, we added another $68.66. On the 11th, we made a payment. So I'm subtracting the $633.60. Well, it looked like I was subtracting. On the 13th, we bought, oh, that's an iTunes. You know what, I think this might be my, no, let's not say this is my actual thing. We did this and we now added $7.49. On the 16th, we did a bunch of things. We added $59.63. We did a $200 charge, and we did a $1.25 charge. Is there anything else for the 16th? 1, 2, 3. Just those 3 things. Okay. So that's that. On the 18th, we did another $8.98 charge. On the 19th, there's a $32 charge. On the 20th, it looks like we have 3 charges on the 20th. So the 44.65 is 1, right? Yeah. Plus the $40 is another, plus another $1.25. And then on the 21st, oops, okay, so wait. Yeah, we got the 20th, 19th. So we did this one, this one, this one. On the 21st, there's a $70.98 charge. Oh boy. And then on the 23rd, we dropped another $1,000. Okay, I think we have it. How does everyone feel? These are the account balances on their respective days. Actually, you know what? I'm going to fix this so it doesn't do what it's doing. I'm going to format this to make it text. And then we can make this 3.10. There we go. And 3.20. So we know what days they are. Okay, so the second process. So if you're writing down if you're tracking how to calculate the average daily balance, you could say step 1 is calculate the balance for each day. Step 2 is figure out how many days is that balance at. So here I'm just going to do 5 minus 1. There's 4 days that the balance remains at 211. And then 5 days that it goes to 1432 from the 5th to the 10th. It remains this balance just for 1 day because we made a payment on the 10th, and then on the 11th we spent some more money. It remains this balance 2 days. Oh, we made the payment, I'm sorry, on the 11th. On the 13th, we have from the 13th to the 16th, it remains that for 3 days, 16th to the 18th, 2, 1 day, 1 day, 1 day. 23 to the 21st, 2 days, and then March has 31 days in it. So from the 23rd to the 31st is 8 days, but that excludes the 31st, right? So if we add in the 31st, it's really 9 days. And that's the like one of the tricky parts. We can double check if our math is right. This should add up to 31, which it does. Is that okay for everyone? I mean, hopefully this isn't the first time you're hearing this. If you're still good, then the next thing we do is multiply the balance times the number of days. Right? Remember doing that. There's the balance times the days. Yikes, 21,000. There it is. And then the average daily balance is the sum of all these things divided by this 31. So I'm just going to type in here average daily balance. That's equal to this number divided by 31. And we don't need to split screen this anymore. And we also need to make this so we can see it. So let's just, there we go, 18. All right. That's the average daily balance. So this is on any given day, or the average of all the days, this is our balance. So anyone remember how to calculate the fee once we get to the average daily balance? Well, let's go back to the worksheet and see. Oh, wait, it says if the monthly interest charge is 2.5% per month. So that means that the interest rate we're being charged is going to be this rate times its average daily balance. So we're just going to take this and multiply times 0.025, and there you have it. We're going to be charged $34.99 for carrying an average daily balance of $1,299.75, roughly. Does that make sense? It's just the interest rate times the average daily balance. Now, to then get the new balance, we take that amount and add it to the ending balance of the month. So we ended owing $2,333.88. When we get into the next month, we're going to add to that this fee, this $34.99. So the new balance is going to be the $2368.82. How's that doing? I know most students, you like eyes just glaze over because most students hate Excel and then blah, blah, blah. But I'm hoping that you're tracking the structure of this calculation. Any questions?
This is gonna be uploaded later today or tomorrow, correct?
Yes. Did I go really
Okay.
fast?
No, I have to leave to go pick up my daughter from school, so,
Ooh, that'll do it too. I'm sorry.
all right, thank you.
Great question, Mike. I haven't decided yet. So be prepared. If I ask you to do this on the final exam, I had better give you access to some Excel, right? Like that's it would be unfair. So I could maybe give access to a Google Sheets thing. Which I think would be a nice idea. Okay, let's see. If there's no further questions, let's look at the 2018 tax bracket. I'm going to let you all do this. I'm going to give you 5 minutes to calculate what is going to be the taxes owed, the 2018 taxes owed on an income, a taxable income of $32,456. So let's see if you remember how to do that. If you don't, let me know. I mean, we don't have to wait 5 minutes if you have no clue. Set a timer for 5 minutes. Anyone got the answer?
I think I have the answer. $3,704.22.
Okay, let's see, because I have no clue. As long as this is what you typed in Desmos, you're good. 0.1 times the 9525 plus 0.12 times the maximum income, which is 32,456, minus that previous maximum income. Nailed it, Mike. Love it. $3,700.04. Sorry, $3,704.22. Excellent. Okay, good. Let's see. Here's a mortgage question. What do we got? 10 minutes. We can do this. So it says, which mortgage is better when choosing a $225,000 home, a 15-year mortgage at 4.21% with 0% down payment, or a 30-year mortgage, 4% with 20% down payment? For the sake of time, I'm just going to work through this one with you. But this is the same question as what is better, a $2,000 down payment or no down payment at all for the car? Meaning, let's get the total cost and then reason our way back through, well, the monthly payment and the total cost, and reason our way back through. So first, take a look at your mortgage stuff. We've got a monthly payment formula we're going to need to work with. We've got a down payment, which is a percent of the cost. We've got the principal is going to be price minus the down payment, and the total cost is just the product and sum. Same structure, same logic as with the previous stuff. Okay, so if we have a 0% down payment, let's just get our mortgage payment. Our monthly payment. So we're going to do the 225,000 times 0.0421 divided by 12. Oops. All that divided by 1 minus 1 plus the 0.0421 divided by 12. And then that is being raised to the negative 15 times 12. Because it's a 15-year loan. There's 12 months per year. So we're looking at a monthly payment of $1,688.08. Interest rates are even higher than that right now. It's a really bad time to buy a house. Okay, so that's going to be the monthly payments. Now notice we made no down payment, so the total cost to purchase this home is going to be the $1,688.08 times the 15 times the 12, right? Because it's that 15 years when making that many payments. So that would be $3,854.40. You know, like what, an extra 80,000 to buy that house spread over 15 years. I guess that's not terrible. Okay, so for the 30-year loan, I'll show you a trick. If we're doing a 20% down payment, that means we're borrowing 80% of the money. So we just need 0.8 of the house remaining. Now, it turns out we do need to know what the down payment is, because we have to add that back in. So 20% of this is just 0.2 times 225. So we do need to keep track of this amount. I guess let's just calculate it right now. So we do need $45,000 up front to get this mortgage. Okay, so then let's calculate the monthly payment. Same thing. Here we're going to do the 225,000 minus the 85. I'm just going to type that as 0.8 times 225,000. So we're borrowing 180,000. We got a slightly lower interest rate. That's nice. So 0.4 divided by 12. And then 1 minus 1 plus 0.04 divided by 12. I screwed this one up, right? This made it a 40% interest rate. That's insanity. And then this is raised to the 15 times 12. Don't forget that negative in there. All right, so this monthly payment's a little bit less, $1,331.44. 200 less a month. That's helpful. Really 350 less a month. Okay, let's get the total cost then. So the cost is this monthly payment times the, oh, this is wrong, y'all. This is 30 years. Let's get that 30 in there. Much better. Oh, that's even way better. Look at that. Only $859.35. That feels super reasonable. You can't find rent in Jackson. You couldn't find a studio in Jackson for this amount, it feels like these days. You might be able to rent a dumpster for that amount. I don't know. Rents are crazy. Okay, so we're going to do this 859.35 times the 30 times 12, but then we have to add to it the $45,000 we had to come up with at the beginning. So when you're talking about, when you answer the question of which mortgage is better, this should play into your thoughts, your discussion of what it is. You have to have $45,000 cash in order to get this loan. That is often a challenge for people. Challenge for me, it would have been, it's impossible for me. Sometimes you can get people to loan you that money, but they have to sign off that it's a gift in order for a bank to accept that. There's some pretty stringent rules, unless you're super wealthy, and then you can just do whatever you want. All right, so this is $354,365.11. So it is what, 51,000 more over the lifetime of the loan. So here's some things to think about. We had to have $45,000 cash up front to get this loan. Our monthly payment is very reasonable, I think, in this day and age. It's not too terrible of a monthly payment, but we end up paying quite a bit over the full lifetime of the loan. Whereas with this one, we had $0 up front. We have a much higher monthly payment, almost double, right? $859 versus $1688. Yeah, almost double. Not quite. But which is a difficult thing. Our monthly budget might not be able to handle that. But then we have much less payment over the lifetime of the loan, and we're paying it down in half the time. So all things to consider when you're talking about what mortgage is best. And that's what I want you to do in your project. You're looking at the scenarios and then just kind of reasoning through it. I want to hear you talk about those different things and what you personally would do. You know, like I've got the $45,000, so I'm going to put that down here and I'm going to make it even, you know, whatever. Okay, so we're just about out of time. This leaves a Unit 3 review for you all to work on. Was today Monday? So I may or may not be able to have class on Wednesday. There may not be a live session on Wednesday. I'm traveling to a conference on Wednesday, and I will be able to log in on my phone and answer questions. So what I want you all to do is work on this unit review B, and then bring those questions on Wednesday. We won't have a formal like lecture time or anything, but I'll be happy to talk through what you're working with, maybe point you to particular reference sheet material that should help you with these problems. Also, you should be working on the Unit 3 project. And what we will do on the Monday before Thanksgiving break, I'm not going to start the new unit. We'll just kind of spend more time talking about these questions on here and your project and getting things settled for just the rush to the end of the semester, which is Unit 4. And the nice thing about Unit 4 is it's not too terrible. It's not a crazy unit. Okay, any questions that you all have?
The only question I have, and I'm assuming it's a no, can we have access to the reference sheet that you did today?
Yeah, definitely. Let's see. I'm just gonna save it and then I will post it to, let's see, unit for your reference sheet. And I'm gonna post it here, and you know what? How about I just email it to everyone in the class? Let's see, new email. Oh, I gotta do it to 2 classes. Oh, that's annoying. Why are there what? Okay, what's the best way to do this? I will, I'm gonna email. It's okay, I'll email. So yes, Mike, that's a very reasonable request, and it is gonna happen.
Sweet. Thank you very much.
You are most welcome. I don't know why I would be recording